Hello, dear students. Here you have some exercises from chapters 1 to chapter 4 that are the ones that you're going to have in the first exam. I prepare these exercises in such a way that you can stop the video at certain time and try to do them by yourself. Let's begin by the first one. The first one was about the scientific method. Here you have an example of how can you design an experiment and try to see if a hypothesis works or no. You can stop the video and you can read this example. But what is most important are the different parts of the scientific method. You always begin by a question. For example, Newton was under a tree and he saw an apple falling down, and he asked a question. Is a force that is attracting these apples to the earth, like the planets are attracted to the sun? And after that, he studied, he made certain research, and he construct a hypothesis. And of course, he made some experiments in order to test the hypothesis until he saw if it was true. Then he reported the results. But if the hypotheses were false, then Newton was supposed to think again and try. Here you can stop the video and read what were the observation, hypothesis, experiment, data analysis, the conclusion, and the law that he formulated after his conclusion, and what he did for communication. You stop the video, and here you have an example of how to use the scientific method. Well, the other thing that is important is uh, what is significant figures in chemistry. Every time you're doing an experiment, the instrument that you use for the measurement has a certain kind of accuracy. According with the accuracy of the instrument, you will have the number of significant figures that you will report in your measurement. For example, in this case, stop the video and try to do this exercise. Determine the number of significant figures in the measurement, and you have this number. The result is here. The significant figures in this number are 5. Which one are the significant figures? Well, 4, 5, 0, and 6. Because the trailing zeros after the decimal point are significant, but not the ones that are to the left of the first number that is different from 0. The zeros to the left are not significant. Here you have 1, 2, 3, 4, 5 different numbers. Well, try to do them. If you have any question, don't hesitate, ask me. You can send me the question by email and I will answer them. Here, you can stop the video also and you can study these examples that I am giving you. For example, in this one, these two zeros are not significant because you don't have a dot. So they are considered um, trailing zeros and they are not significant. In this case, for example, that you have a zero between 6 and 7, it is considered a significant figure. And look at this. This one, this zero after the 5 is significant because you have a decimal point. But in this case, these zeros to the left are not significant. You can stop the video and study each case. The international system of units is the one that we use in sciences. Here you have the prefixes that we can use and the multiple that is used to express every fraction in the international system, as I told you before. The units are the kilogram, the meter, the second, the mole, and uh, also you have this derived in units, the volume, the density. We use the density, so pay attention to this. Also, it's important the energy and pressure that we are going to use in this class. But in United States, we use the English system. So you can see the uh, equivalence between the mile and the kilometer, the foot and the meter, the inch and the centimeter, and so on. So uh, in the exam, you can use these conversions. You don't have to memorize them. All what you have to do is to show me in the camera what are you using and I will approve it. Remember, you can use only in camera a calculator, the pencil. You can use a piece of paper in blank to do certain kind of calculation that you need to. If you want to send me these calculations, well, it could be good because if I see that your answer is incorrect, but the operation that you have done are okay, then I can give you partial credit in the exam. Then remember, you can have this table, you can print it, and you can show me in the camera that you're going to use it. And it's fine. Well, in order to measure temperature, we have three scales: Fahrenheit, centigrade, or Celsius, and Kelvin. Here you have the scales, and here you have certain conversions that you can use also. You can add this to the piece of paper that I will allow you to use. You show me in camera, and then I will allow you to use these formulas. You don't have to memorize them. Well, let's continue. In order to calculate density, what is exactly density? Density is a relationship between mass and volume. Generally, the density is given in grams per cube centimeter. There is an equivalence between a cube centimeter and 1 milliliter. That's why sometimes you see cube centimeters, sometimes you see milliliter because they are equivalent. They are not the same, but they are equivalent. One of the methods that you can use to measure the volume of a body, a, a piece of metal or something like that, is the water displacement. You put certain amount of water in a graduated cylinder and then you introduce the object and then you subtract the final volume minus the initial one, and you get that the volume of the piece of metal or whatever is 30 milliliters. In other words, is 30 cube centimeter. This diagram that you can see here is helpful. For example, if you want to calculate density, you say, oh, is mass over volume. But if you want to calculate volume, you say, oh, is mass divided by density. If you want to calculate the mass, you multiply the density times the volume. There are certain ways to calculate the volume of different objects. For example, if it is a prism, well, the volume of a prism is the base times the height, but the base is equal to the length times the width. So the volume is length, width, height. And in the case of a cylinder, then the base is equal to P R squared. This is the base. The base is equal to this. Then you multiply by the height and you get the volume of the cylinder. Atoms, ions, and compounds. Here we have an exercise. For example, you have carbon 14, 6. What is 14? 14 is the atomic mass. And what is 6? Is the atomic number. If you subtract atomic mass minus atomic number, you get the number of protons. Remember that the protons are in the nucleus and they are neutral, no positive, no negative. But this number, the number 6, the atomic number, represents the number of protons. So we can say that in this case, the atom of carbon has 6 protons, and 14 minus 6 is 8. Sorry, I put here protons, and it's neutrons, sorry. Neutrons, and has 8 neutrons, sorry. And as the atom is neutral, it has the same number of protons that are positive than electrons that are negative. So the atomic number is giving you the number of protons and also is the number of electrons since the atom is neutral. Look at this case. In this case, carbon has atomic mass 12. So it has 6 protons, 6 neutrons, and 6 electrons. Stop the video and try to solve this problem, these exercises by yourself. The cations, for example, here we have the sodium atom used to, for example, it has 11 electrons, but the cations used to lose electrons and they are converted into a cation. In this case, sodium plus 1 because sodium loses 1 electron. It happens the same in lithium. Lithium loses the outermost electron and makes a cation, lithium cation, and is releasing 1 electron. But this electron is gained, look at this, sodium loses 1 electron, and this electron is gained by another atom that in this case will be negative. The negative ions are the anions, and the positive ions are the cations. In the case of the cation, you say the name of the element and the word cation. Sodium, cation. In the case of the anions, change the N. For example, the element is chlorine. What happened? That you changed the ending by "ide." And then you say chloride. The anion always ends in "ide." Chlorine, chloride. In this case, when an atom releases 1 electron and the other gains 1 electron, well, 1 electron, 2 or 3, depends on the type of element. These compounds that are the result, as they are made of ions, positive and negative, these compounds are known as ionic. Ionic compounds because they are made of ions. Stop the video and try to take note of this. Look at this. Cations, sodium forms the cation losing 1 electron. Then we have sodium cation. Chlorine forms an ion by gaining 1 electron. Then this is chloride. Magnesium loses 2 electrons to make a cation that is magnesium cation. But oxygen gains 2 electrons in order to make the oxide. In this case, the name of the anion is oxide. For example, Mg positive 2 with O negative 2, they make a compound that is named magnesium oxide. But the name will be in the following chapter. Here you have more examples: calcium, fluoride, potassium, and nitrogen. You can stop the video and take note of all these examples. Well, what is matter? We can say that matter is anything that has mass and has some weight. In this case, sorry, this is not what I wanted to say. Has mass and occupies a volume, sorry. Then anything that has mass and occupy, occupies a volume and a space is matter. We can call it matter. Matter can has different kind of changes. From solid to liquid is melting. But if we go in the opposite way, from liquid to solid is freezing. From liquid to gas is vaporization. And from gas to liquid is condensation. But there is also a change of state from solid to gas directly. And this is sublimation. The opposite from gas to solid is reverse sublimation or negative sublimation, also known by negative sublimation. For example, water boils at 100 Celsius degree, changing from liquid to gas. This is a physical change. But when iron reacts with oxygen to form rust, this is a chemical change. What is the difference between a physical and a chemical change? That in the physical change, water continues being water, even though it is in the liquid, the gas, or the solid state. But in a chemical change, matter changes. At the beginning, you have iron and oxygen, and at the end, you have an oxide. That is this one. So it's a different compound. That's why we call rusting iron a chemical change, while water going from solid to liquid or to gas is a physical change. Here you have more examples of chemical change. For example, the flame here, when you have a flame, is because there is a combustion reaction, and at the beginning you have a compound and at the end you have carbon dioxide and water vapor. In any kind of reaction, chemical reaction, you will have a chemical change. Also, when you are cooking, the food uh, uh, is changing when you are cooking the food, and then you have at the end a different substance. The same thing happened when, for example, bananas are going darker because they are more than yellow. So at the end, it's a different system from the one that you have at the beginning. All these cases are chemical changes. You can be sure that you are in front of a chemical change when you see light, when you smell something, when there is a change of color, when there is um, a gas produced, or when something is precipitated. So here you have different types of method to separate mixtures. Remember that a mixture is when you have different compounds together, and they can be homogeneous or heterogeneous. We are going to speak about this later. But now, let's see, for example, describe a method to separate sand from seawater, salt water, sorry. Well, in this case, you can use filtration. This method that you can see here, when you are filtrating the salt water with the sand, the sand remains here in the funnel while the salt water goes down. Also, you can separate two liquids that are not miscible when you by decantation, then or a precipitate. Also, you can separate a precipitate from the liquid by decantation. Also, when you have two liquids that are miscible, you can separate them according with the boiling point. When you begin heating here, the one with the lower boiling point goes to the gas state and here condensed, and you can have the the one with the lower uh, boiling point, the more volatile in the distillate. This is a way we can separate, for example, alcohol from water. Water boils at 100 Celsius, while alcohol boils at around 80 degrees. So alcohol will go to the gas state first than water. For example, when you have water and oil, you can separate the water from the oil using this kind of funnel. Well, these are different methods that you can use to separate mixtures. In general, we can say that matter can be divided into pure substances that also can be divided into the element and compounds. Compounds has more than one element. For example, nitrogen is an element while hydrochloric acid is a compound. But when you have more than one compound together, you can find a mixture. If it is uniform, it is homogeneous. If it is not uniform, then it is heterogeneous. Here you can see in a homogeneous mixture, you cannot see what is one element and the other, but in a heterogeneous, it's quite easy to see which one is which one. Energy. What is exactly energy? We can say that energy is the ability to do work. And this energy can be transferred from one form to another, but it cannot be destroyed or created. This is the law of conservation of energy. We have different kind of energy. For example, this is electric energy. Then you have also, for example, chemical change, thermal change, magnetic, energy, magnetic energy, electrical energy, thermal energy, or you can have, for example, potential energy. When the apple is on the tree, it has a lot of potential energy. But when it is falling down, it has kinetic energy. The internal energy is the energy contained in a system, and it can be kinetic or potential energy. And for example, we can say that the internal energy depends on the amount of heat or the work done by or against the system. This is the work. Then the internal energy is equal to Q, that is amount of heat, minus W, that is the work. Well, the thermal energy Q uh, is usually measured in joules or calories. The mass of the substance is in grams or kilograms, and the specific heat capacity of the substance is in joule per gram per Celsius degree or in joules per kilogram per Celsius degree. And the change of temperature is measured in Celsius or in Kelvin. So we can calculate the amount of heat using this formula. If you have the mass of water, if you have the specific heat of water and you have the change of the temperature of the water in the process, you can calculate the amount of heat that is gained. The amount of heat can be gained or lost. According with this, the process is exothermic if releases energy, or endothermic if gains energy, if absorbs an energy. Then heat is the energy transfer between a system and its surroundings. Due to what? To the difference of temperature. For example, if you have water and you have here a flame, the flame will change the temperature of the water inside a bottle. And work is an energy the transfer that occurs when a force is applied to an object causing it to move. Remember that work depends on the force that is applied to a body and the space that this force move the object. The work can be done on a system or can be done by the system. The first law of thermodynamics expresses that the internal energy is equal to Q minus work. Well, two important forms of energy is the kinetic energy that is related to the movement, to motion, and the potential energy that depends on the high an object is. For example, this kicker does work on the ball, giving a maximum of kinetic energy, and then you can see the ball that is moving. In this case, it has kinetic energy. But when it is at the top of the curve, we can say that in this case, the ball has potential energy and also has a lot of potential energy when it is on the floor, for example. Then the potential energy depends on what? In the height an object is. Let's do this exercise. You can stop the video at any time. I want you to calculate the amount of heat that is absorbed by a mass of water, 200 grams of water. Here the specific heat of water is given, and then you calculate the change of temperature that is from 75 to 25. Then the change of temperature is 50 Celsius degree. Then you multiply 200 by 4.18 by 50, and you get that the amount of heat that is absorbed by the water is 41,800 joules. You can change this into kilojoules divided by 1,000, then it will be 41.8 kilojoules. Well, here is more or less what I wanted you to study, or some of the exercises that you can study for the first exam. Anyway, if you have any doubt, you can send me an email and we can meet via WebEx. All right? Thank you, and I hope that you understood.